By 2010, around 25% of Japan's population is expected to be aged 65 and over. With the rapid aging of society in Japan, people believe that robots will be able to provide various services in our daily life and will become indispensable. Conventional industrial robots are designed for simple, common tasks. Large numbers of robots are already used for repetitive tasks in factories. However, future service robots will have to meet the highly diverse requirements of each user and deal with various complicated tasks. Generally speaking, robots consist of various functional elements, including robot arms, mobile bases, and a variety of sensors. Currently, each manufacturer develops robots according to their own unique design rules. As a result, developing the software for new robots with multi-vendor components requires considerable knowledge and effort. This project proposes an open robot architecture based on software modularization of robot elements. RT middleware is developed as the fundamental software for developing the robot system. Using this technology, various service robots can be easily developed. RT middleware helps us to create modules with standard interfaces. From now on, we will call these modules RT components. The RT middleware consists of RT components, which form the middleware's framework, and supporting programming tools to operationalize the RT components as programs. An RT component consists of command interfaces, input interfaces, output interfaces, and RT function activity. This activity realizes original RT functions, such as servo control and sensor processing. Input and output interfaces are used for data transfer between RT components. Command interfaces are used for slower communications, such as acquiring information from components and switching operations. These interfaces are implemented as distributed objects. RT components can be handled in the same manner irrespective of their implementation languages, operation systems, computer hardware, or network configuration. The RT middleware programming tools include an RT component builder, which supports the creation of new components. An RT component composer, which supports the combination of components to form new ones. And a graphic user interface, which connects up existing components to create new functions and controls RT component operations. The programming tools can have a range of other functions as well. As one example of RT middleware, this project developed OpenRTM AIST. This is an example of a robot arm control system developed using the RT middleware. The system is developed in 3 steps: specification setting, component development, and system integration. The system to be developed here uses a joystick to manipulate a force-controlled robot arm. After specification setting comes component development. The following 4 components, crucial for the construction of the system, were developed. An arm component with a port for receiving speed commands for the arm's end effector. A force sensor component with a port for outputting force and torque. a joystick component with a port for outputting applied force and torque to the joystick, and a controller component using damping force control laws. A further 2 components were also developed for system coordination. A slider component to regulate the feedback gain, and a data logger component to display and store the data from component output ports. When the necessary components are ready, systems integration begins. The system can be put together quite easily by connecting the components' input and output ports. Next, the completed system is test run with real-time control. The arm is manipulated by a joystick. Its force can also be controlled. The slider component can provide real-time gain adjustment. The data logger component allows output to be monitored. Simply connect it to the port of the component whose output you wish to check. This graph shows the operating force to the force sensor. If you disconnect the output from the force sensor component, the arm does not respond to force. Then, when the force sensor output is reconnected, the system responds again. It is very easy to change the configuration of the system. The system's real-time features rely on Arch Linux. The general-purpose features of the RT components make building and modifying RT systems simple. Systems can be easily developed for various needs. Because the RT components all share the same specifications, they can be used interchangeably. For example, if we design the arm of a humanoid robot as an RT arm component, it can also be operated using the joystick component. Next, let's take a look at an RT space, another demonstration of the effectiveness of the RT middleware. In the RT space, multiple sensors, actuators, and other robotic elements collaborate through a local network to produce a complete lifestyle support application. So how does the RT space work? When controlling the robot with a PDA, for example, commands issued from the PDA ask the configuration server for the appropriate robot operating script and are executed by the script service. The request is made through the home server's action proxy. At that time, the naming service is asked for the network address of the RT component specified in the relevant robot operations script. Using the network address obtained, a command is sent to the RT component and the action is executed. Let's look at an example of a robot system developed using the RT middleware. The person in charge of building the RT space, the RT integrator, takes care of the whole process, from selection of the RT components to creation of the application software, customizing the process to the user's needs. The modularization of robotic functionalities into independent RT components makes it easy to design an RT application that exactly suits a user's needs. And the wide range of services and graphical tools provided with the RT middleware greatly facilitates the building process. The RT middleware easily accommodates the addition, modification, replacement, and removal of RT components, independently of individual makers. Finally, the robot is delivered to the user. Any modifications requested by the user can readily be performed on the spot by the integrator using the RT middleware tools and services. This includes modification or expansion of functions even after delivery. Here, a new function has been added to the robot: the ability to fetch a drink from the fridge. A wide range of RT components is already envisaged for living environments. These include security systems, home appliances, house equipment, and eventually mobile robots. The RT space can be controlled from inside the home by directly sending requests to the home server and connecting the system to the internet via the home gateway allows you to control the system even when away from home. RT middleware technology will help create new markets. Even small venture companies will be able to offer RT components with their own unique and specialized technology. Through division of labor and specialization of the service robot industry, integration business will be born. RT middleware technology is the key to reforming the structure of the robot industry. We have already started working toward the standardization of RT middleware. This innovative technology should make possible the development of robots that can respond to the diverse needs of everyday life.